And I'm Nazar.
Today we'll be going through our application for our 3102 Yolo. So let's first off take a look at how our Docker system architecture is being done. So all of our Angular and load balancing and YOLO backend is actually being hosted on Nginx, which is on Docker itself. So whenever a client does a request on Angular, which is the client, it will be handed over to the Nginx load balancer, which is then going to the YOLO backend application.
So basically, what happens is that whenever there's a request, Nginx load balancer will check which service has the number of least connections, and then it would forward that specific request to. So all these containers and services are hosted in a Docker environment, so it's Dockerized.
Moving on, let's take a look at our Docker file and Nginx configuration.
Okay, so basically initially we have this 3102 YOLO service docker file. So what happens here is all the dependencies and the Python requirements are all initialized here. So to speed it up our process, what we initially did was to get all these requirements ready, and we push it to Docker Hub as it's indicated here. So once this image is hosted in Docker Hub, all we have to do now is run this Docker file where we pull the Docker image instance, and then we just copy over our YOLO Python file over to the project folder, and we do a flash run. So doing this, we will save time on installing all the necessary requirements, and all we have to do now is just download that image and simply run. So as you can look into the Docker Compose file, we have two services. One is YOLO and YOLO 2 service. So both these services will be initialized at the start of the Docker Compose, and then there is also a Nginx service, and our front end Angular client will be hosted in Nginx. So this is the Nginx configuration file. As we can see, we have a upstream backend where Nginx will load balance based on the number of least connections on either YOLO or YOLO 2 service. So all the incoming requests where there is /API will be forwarded to the upstream backend server. So now let's take a look at how our Docker Compose works. Okay, so now let's Docker Compose up and see what happens. Okay, so now the YOLO REST service and the Nginx services have all started successfully. So to check whether our load balancing is working correctly, let's bash into each of the YOLO service. And YOLO service 2. Okay, so when images are sent to the service, it will be saved in this folder called /images. Just currently in YOLO service 1 and YOLO service 2. So what we're going to do here is we're going to open two instances of YOLO service, and this is to ensure that the load balancing is done correctly. So for the first service, we would select 3 images. And let's select another 3 images for the other instance. So let's try to click upload as quickly as possible to see if the load balancing is done correctly. So as you can see, we get reply from both the services. So now let's go back to the service and check if all the images are split into two requests. So in the first service there are three images, and in the second service there's another three images. So this shows that our load balancing is done correctly, as request 1 is forwarded to YOLO service 1 and request 2 is forwarded to YOLO service 2. So now we will go through the features of the YOLO web client.
Alright, so as you can see on the left, there's a word cloud. So the purpose of the word cloud is actually displays the confidence level as sizes within the cloud. So if we go here, we can see a person. If we go to the second image, we can see a bunch of cars. Then based on the confidence level, it's being reflected on the cloud. Other than that, the user is also able to export the image. For example, I have this picture of NYC. When I export it, I can just save accordingly as an image. And yeah, pretty much that's all our
Thank
app
you.
does. Thank you.